Great. So thank you, as I said, everyone, for being here. I've set a very low bar for myself for this session. So if you are able to remember just one thing of the session, please tweet it to me. You can see my Twitter handle right here. I would love to hear from you. So today I'm going to talk about Project Amber, which was started in early 2017. And this is the official page by Oracle, and you can get all the details if you visit this URL. So as I asked right before the session, so most of you are on Oracle on Java 8. So the changes that I would be talking in Java language would start from Java 10 because Project Amber was started in early 2017. So you would miss just a couple of language changes from Java 9, which is using safe var args, about having private interface methods in interfaces, and just a couple of them. So we'll start our journey with Java 10. So the goal of Project Amber is to explore, incubate smaller, productivity-oriented Java language features. So how many of you did understand that one? None, okay, no problem. So let me simplify that for you. So you can think of Project Amber as an umbrella under which new changes, new additions to Java language are done. We are also talking about new additions to the language, and we are also talking about the enhancements to the existing features. So as you can see those bubbles there. We have var, which was introduced with Java 10. So I see a lot of nodding there. That's great. So we have switch expressions, which was recently released with Java 12. We have records and pattern matching, which is still in works at Oracle. So when we talk about the language changes, so these are worked in as smaller sub-projects under Project Amber, which are called the JEBs. They are talked about, discussed, debated, rejected, accepted, worked on, and then released with a particular Java version. And Project Amber is not one big change. We are talking about smaller changes to the Java language, and which are as I said, some of these have already been released with recent Java versions, and some are yet to be released. So this brings us to, I believe, the most important question for this session. Why should you care about Project Amber? Okay, I understand that we are talking about smaller changes because we have very big changes coming in projects like Loom, Valhalla, Panama. Anyone heard about all these projects? Panama, Valhalla, Loom, okay. So these are other projects which are in works at Oracle. Probably we'll have separate sessions for those projects, which are bringing in a lot of changes to Java language, platform, and the tools. Again, going back to the question, we care about Project Amber. So even though we are talking about smaller language changes, when we put them all together, that will really make a lot of difference in how you read and write your code every day. So all these three words are important: reading code, writing code, and your everyday code. Even though you might just skip writing code using these features, you would still get to a point where you have to read the code written by other developers who are using these features. So as you already mentioned, a lot of you are using Java 8, but the ones who are not using Java 8, do you get to read the code which uses, let's say, lambda expressions? Yes, we all do. So even if we are not writing the code ourselves, we get to read the code which is written by other developers who would be using the newer features. So yes, the changes are important. So just in case if the statements didn't resonate, here are some quick examples where you can see how Java has changed in recent versions. So this is with the recent changes in Java 10. So the upper side shows usage of, so the bottom part shows var restricted keyword, which is used to define local variables. We talk about switch expressions, which was released in Java 12. So if you try to compare it with the traditional switch statements, there are a lot of changes here, which I have tried to highlight with the green boxes. So this is how you might write your methods in future. So this is concise method bodies, kind of resonates with how you write Lambda functions. So this is how you might write your methods in Java in future. And this is a sealed interface. So here we are trying to restrict which classes or interfaces can extend our classes or interfaces. So this is how Java is planning to change in the future versions. So I also mentioned that we are talking about smaller projects under the project Amber. So are there any stages? I also mentioned a couple of nouns just some time back. So there are multiple stages. As we know, Java is more than 20 years old, and we just can't afford to add new features or enhance its existing features and break the code which is already working on it. So a lot of caution is taken when Oracle updates the language features. So here are the stages through which every enhancement or addition goes through. It goes through draft, submitted, candidate, proposed to target, integrated. And if you could see the light blue lines, at every stage, a feature could be dropped, closed, or withdrawn. So how many of you have been following the string literals in Java, which was, okay, a couple of hands. So yes, and do you also know that now it's no longer called switch literals, and there are changes, and it has been withdrawn. And now instead of string literals, we have text blocks, which is coming in Java 13. So a lot of caution is taken, and they could be withdrawn at any stage. And what are the release dates? So a couple of the projects which I would be talking about have already been released with the recent releases of Java, and some other, they don't have a release date yet. Oracle has a release date for them as and when they are ready to be released with a new Java version. So how many of you would agree with this statement? Change is constant. Good. Change is inevitable. So whether we like it or not, change will happen. Right, most of us? Change is beautiful. Is that so? I would come back to this statement again, because change is not always beautiful. Even though change is not beautiful, we have to change because it's neither the strongest nor the most intelligent that survives, but it's the one who is most adaptable to change. We all agree with this statement. And this one would make more sense. Change is painful. Ouch. How many times do you have to change and you get that ouch? All of us. Yes, a big I love that. So the whole purpose of you attending this session is when you change, how difficult the change is, how painful the change is, it also depends how, are you forcing the change? Are you seeing that the change is coming? Do you know about the change? Do you know how much you would have to change to adapt to the change? A lot of other things apart from just the change. So if you see things are changing, if you know how they are changing, then the change would be less painful and we would have less number of ouches. So in this session, I would cover these topics. I would not read them out because we will cover them as we move on. I would cover some of these topics in detail because I got a lot of feedback from people that they want some topics to be covered in detail rather than the others. So let's get started with type inference with var, which was released with Java 10. So when we talk about var keyword, so var is a restricted type in Java, and type inference, okay. So how many of you would know what is type inference? Okay, so most of us. A quick exercise to understand what it actually is. So let me show you this puzzle, and then I would give you some quick options to determine which piece would fit in here. Do you think this one fits in? No. This one? Do you think this one fits in? Yes. So this is what type inference is. With the clues that you already have in the image, you are able to tell the other person what you want. In the same way, with type inference in Java, the compiler can infer the type of the variable that you are trying to code, but all the information is already there in the code that you write. And type inference with var is limited to local variables in Java because if we take it to public variables or static variables, then we get to spill it into the API, and then it gets difficult. So I'll have a quick demo here. Okay, so yes. Is this legible at the back? No, I don't think so. So let me just change the font. And is this legible at the back now? Oh, great, thanks. So let's get started by defining, let's say, a few local variables. And I would be using the explicit type to start with, and then I would change it to var. Let's say the name is Java is everywhere. We all agree with that, don't we? Yes? No? Okay, so I say local date time is equal to local date time dot now, and then I say hash map, I say string, and integer I say map is equal to new hash map. Right. Now in this case, all the local variables that I've used here, they include an explicit data type. So what I can do now is I can go back and I can replace the type with var. So this is simple with, so I'm using IntelliJ IDEA here, which is by JetBrains. So these are the suggestions which I get when I work with IntelliJ IDEA. So some magic is going to happen here. So if you notice hash map, the code on the left side has the type information string and integer. Now it will magically move to the left side. Can you see that? Thank you so much. So Hadi, that's for you. Okay, so in this case, I missed mentioning one point, that this is syntactic sugar. So when you use var, the compiler lets you drop the explicit data types, but it still has all the type information. The compiler has all the type information, and you can actually go back and check this here. So if I say control in Q, sorry, I can see that the type of the variable is local date time, even if I have written var here. So the compiler knows all the information. But again, as I said, you must provide all the information to the compiler to infer its type. But what if you don't? So what happens if I say age is equal to, let's say, null? What will happen in this case? Do you think the compiler would get to know what the age is, what the type of the age is? No? That's right. What happens if I say name 2 is nothing? Again, in this case, the compiler doesn't get all the information that it needs, and so the code will not compile. So I have an image to show to you. By this image, I'm trying to emphasize that the compiler should have all the information it needs to infer the type, or else it will not compile your code. So let's have another example. And here I'm trying to say, have an array, and I say is equal to, I say S and T. What happens if I modify this to var? Do you think that will work? No, again, because I'm trying to assign something to a variable without giving it all the information that it needs to infer the type of the variable. So this is what I wanted to show from the previous line of code. Using var is cool, and a lot of time when I'm trying to show you by changing the explicit data type to var, us developers, we just like to chop off the explicit type and replace it with var, and that doesn't work. Okay. Again, if I talk about, let's say, insufficient values, let's have a function, and I would say this is string and integer, and then I call it function, and I say, okay, I say integer dot value of I. So again, if I try to replace this by var, it will not compile, again because I'm giving it insufficient values. So if I try to press Alt Enter, I do not get the suggestion by IntelliJ IDEA that I could replace it. But if I try to do that anyways, then I get a compilation error. Right? And again, this would have the same effect if we talk about, let's say, the method references. I could replace this lambda with a method reference, and again, if I try to replace it with var, it will not work. And if I drop that forcefully, if I do this one, then again it will not work. So whenever you are trying to pass insufficient values, the code will not compile with var. So I have a quick cheat sheet for you, and you can quickly look at where you can and you can't use var. So this is for you to see, and I would have questions for you in another 10 seconds, and your time starts now. This is also to re-emphasize what I say and what the other person understands, because I've been saying that var is used with the local variables, but a lot of time what a local variable is and where it is defined, it gets confusing, because a lot of time we think that a local variable could be defined at places x, y, z, but that could be wrong or right. So now here's a question for you. You see two places which are underlined, the var. Do you think the first one is correct? Do you think the first one will compile? I have deliberately not used the IDE because that one highlights the errors. Okay, no answers for question 1. What about the second one? Do you think the second line, the second usage of var will compile? How many for yes? Okay, and how many for no? Okay, so the answer is no. It will not compile in both the cases. Okay, so let me have another one for you. So I have person. Okay, so this one I have deliberately commented so that you don't know the answer. So, do you think this one will compile? Okay, great. How many think that it will not compile? Just a few. Oh, that's good. But the answer is yes, it will compile. What about this one? It compiles, right? Okay. Oh, that's great. I didn't think of so many yes. I was thinking the other way around. So good, you're doing a good job. Okay, now let's move on to the other one. First line of code. How many of you think that will compile? How many for yes? You all are wrong. It will not compile. So, how many yes for the second line of code? Okay, and how many say that the second line of code will not compile? You all are wrong. So feels so better, right? What about the third line of code? How many of you think the third line of code will compile? How many for yes? Okay. And how many for no? And what about the rest? Undecided? Okay, so that's for you to find out will the third line of code will compile or not. Okay, so let me tell you, it will compile. What about? First and second. So what's the default type of int literal values? Is that int, right? But what about the value that you have on the right side of the equal sign? Will that fit into an int? No. So this is where what we think should happen mismatches with what actually happens. Because when you use var, you just look at both sides of the equal sign. Is the content that you have on the right side, is that good? Will that compile? And then try to assign it to the one that you have on the left side. And again, there has to be a match. You should have all the information that the compiler needs to use var. It should be compatible. The first line doesn't compile because the type is int and there's a mismatch. If that big value cannot be used as an int literal value, it has to be a long value, which is the second line of code, which has the L suffix at the end. So this is what sums up what we just did. We as developers have a lot of assumptions, and we try to complain the other person that you are not doing the things right, but actually in the other, it's a lot of time it's the other way around. So in this case, the compiler already has known its rules forever, and we should be more aware of how things work. Any guesses? What's the type? How many hands for float? Okay, and how many hands for double? Okay, so the double ones are right. Float ones, we really have to go back and do a lot of work. Okay, so type inference with derived classes. So that's a quick code which is here. So parent class and child class. Parent class is one method. Child class has, of course, two methods. But in the line, the third line from below, so what is happening is you are assigning an instance of child here. So what do you think should be the type of variable obj, object? Would that be parent? That would be child. So that's quite obvious. So what happens here? We have the same parent in the child class, but now we have a method which is getObject, and the return type of the object is parent. So what happens to the type of obj here? Would that be child? How many hands for child? How many hands for parent? The others, undecided. Compiler error, yes, because the type of, the return type of method get object is parent. So doesn't matter what you pass to the method as an parameter, you always get the type is inferred as parent, and that's why you get the compilation error. So we really need to know our basics right to get to work with a new feature. So again, a quick example with generics. So this is how you would usually define your variables that uses generics. So when I use IntelliJ IDEA and I used the intention, the type information was automatically shifted to the code on the right side of the equals. But if you don't do that, you end up having a raw data type, and then you might pollute what you're adding to your collections. So in this case, if I don't have any type information, I could add different type of data, which is not what we expect or want. Now the last question for the var type is this, will this compile? How many hands? Yes. How many hands say this will not compile? Okay, a few, and the rest undecided. Yes, so this will compile. You can actually explicit cast the null literal to a type, which is string in this case, and then you could assign it to the variable name, the variable var. So this will compile even though we cannot assign null to a data type with type var. So to sum it up, using var is convenient, it's concise. We are taking off the parts which are redundant. That of course improves the readability of our code, and Java is still a type safe language. We are not moving to dynamic. It's still statically typed. We are not becoming a dynamically typed language. So now, that was the additions to Java in Java language in Java 10. Now we'll quickly cover local variable syntax for lambda parameters in Java 11. So as you already said, most of you are on Java 8. So you would identify how we write lambdas like this, right? And we could also write lambdas like this, right? So this is explicit, using explicit types, and this was implicit type, right? With Java 11, I could replace the explicit type with var. And what are the benefits? We're just aligning it with the usage of var as we had in Java 10. The other benefit is, with using var, you could also use your annotations, because if I drop the type and if I go for implicit type, then I cannot use the annotation. But with using var with your lambda parameters, you could also use the annotations like non-null. So that was the only additions we have from Project Amber to Java 11. Now, so this one's quite hot, switch expressions. So we'll have a quick demo here. Let me go to the file. Okay. So switch expressions, a brief introduction. So the way we have been defining our switch statements, they are more like multi-if-else statements. We have if, switch, this matches case, we do this, and so on. But this is going to change with switch expressions. Now we could return a value from your switch statements, of course, with expressions. So let's define an enum. I call it as single use plastic. Let me have the constants as spoon, I have fork, I have a bottle, and let me have a cup as well. And now let me define a method. Let's try to calculate the damage that we are doing to our planet by using single-use plastic items. Oops. Okay, so I have a variable result, and I assign this a value 0, and I return result. So let's see how we would be using the switch statements. I switch on the method parameter, and then I say case spoon, and I say damage is equal to, result is equal to, let's say 10 points. I say, of course, there has to be a break, otherwise the control falls through the other case label. Then I say case fork, and I say result is, I say 10 again. Then I have the mandatory break statement. I say case bottle, and I guess, so this one's result. And I'm deliberately making it not so much of a line code. So let's say the result, let's say the damage is the most if you use single-use plastic bottles. So guys, please don't. So I have case cup, and then I say result is equal to, let's say 5, and of course the mandatory break statement. Okay, so I could format the code using a shortcut, and if you can see, you can actually see the shortcut that I use at the bottom of the screen. And now let me change this to a switch expression. So if you can, when you read through the code, you can see a lot of repetition. I have a break statement after every case, and of course the assignment also results 10, result 10. So that's a lot of repetition. So now let's use the switch expression and take the repetition off. So I say Alt Enter, and I choose replace with switch expressions. So isn't that nice? Oh, thank you so much. So again, we are losing a lot of break statements, a lot of repetition, and there's some more magic here. If I don't know if you can see from the back, but 10 is underlined, and if I say Alt Enter again, it says you can merge with case spoon. So let me select that. So the switch statements, thank you. So with switch statements, I can take off the break statement. I no longer have to go through using the break statements to not have a default fall through. I can use multiple case labels in the same branch. I can see the developers being so happy by seeing that just one small change. And of course, I have a default here. Okay, now I can also inline this variable, and I can say just return this one. Now, one change here. As you can see, this is returning a value. What happens if I take off this line of code? If I delete that? Will that still compile? Okay. What if I do this one again? No, this will not compile in this case, because we are talking about returning value from switch expressions, and if we do not cover all the cases, we are not talking about covering the exhaustive cases, then it will not compile, because the switch expression must be able to return a value. So in this case, either I could add a default label, or I could add the missing labels. But what happens if, let's say, instead of switching on plastic, I say I switch on a number. So if I say a value here, in this case, okay, so I'll have to change this one here and this one here. So in this case, for data types like int or string or other values on which I could use switch on. I cannot have an exhaustive list of values on which I can switch. So in this case, I could just have a default label and I could say return a value. And this is not all. You can have a block here and you could define multiple statements here. Let's say I have system out.println. I could define local variables here. So this is a local var. I could assign any value. I can even go out for a walk. Then what happens? How do I return the value here? I can use the break statement to return the value. Now this will compile. So I could have blocks within a case label. I could define the local variables. I could define anything that I want to, but the value would be returned using a break statement. This has changed with Java. This will change with Java 13. So I missed mentioning one point, that switch expressions were released as a preview language feature in Java 12. So that really means that even though Oracle has given the feature to developers for trying out, of course it's complete feature, it is not a feature which is incomplete, but still they are seeking the feedback of the developers on the feature. So if there are any major issues with the feature, Oracle is listening and they are changing. So the break 10 statement was confusing to a lot of developers, and this was the feedback that Oracle received. So they initially changed it to break hyphen with, and then now it has changed to yield, Y-I-E-L-D. So because I have Java 12 on my system, this will not compile as of now, but with Java 13 you can see the switch statements have been released with a new, with just one change, which is this, to returning the value. Okay, so next. So of course we talked about returning values versus executing statements. You could still use the switch statements expressions as you might not be returning the values. You can use them as switch statements as well. We also covered the exhaustive cases, the default fall through. We don't really have to think about whether the missing break statement is the way how the developer wanted it to be, or it's just a missing break statement. We talked about the preview language features. Okay, now we talk about the text blocks, which is coming in Java 13. You already have the early access builds and you can actually go and try it out. So how many of you have ever tried to store this value in as a string? Some of us, most of us, right? So this is how you would ideally use to have it in your strings. Perhaps like this as well, if you are brave enough to use all those new line and tabs. What about this? The life gets more miserable when we talk about the regex expressions and JSONs. So with Java 13, it would be as simple as using 3 opening and closing codes. Anything? Oh, great. Thank you so much. So the developers are really happy. I should tell Brian about this. So Brian was really asking about the feedback on what are the features that developers are really looking forward to. I'll definitely share this with him. So by using 3 opening and closing double quotes, everything that goes in between becomes a string, and you can have your regex expressions, your XMLs, your JSONs, anything and everything there. And you could use that as your regular string. So we don't have a new string, that's still a regular string that we have been using. Okay, so we'll quickly go through some of the new changes that we can expect. Now let's talk about records. So let me see if I already have a file or I have to create one. Okay, so let me create a new class. So what happens if you want to, let's say, have a class where you just want to use it as a wrapper for your data. When let's say you are adding the details of your employee to your database, you're sending it as an XML file and things like that. So this is how you typically do that. So I'll have only just 2 variables to keep it simple. Of course, you could no. Can anyone help me with how to insert code? Sorry? Alt, insert, no. Okay, thank you so much. So this is how you generate a lot of code, and you say you want the constructors, you want the getter and setters for your fields, and you want equals and hash codes. Okay, and you have just last one, which is the toString, right? But of course, your IDE can really help you with adding all this code, because we have been told from ages that encapsulation is a good thing, and you must not make your data public, and you must have all those getters and setters so that you can actually control what's going on in your fields. But this is actually we usually write our code. There's no validations in here. So even if the IDE can help us insert the code, what happens if I change some of the code here? Let's say this thing. What happens when you read the code? Then you don't have the help of the IDE to know whether the code was auto-generated or whether it has been modified. And what you have been doing is to have just a wrapper class, so that you have you just want to store the details of an employee to a database or to any persistent state. So with records, this is what you would be able to do. The language would provide you with a keyword that you can use, and by just saying record EMP string name and int age, you would not need all that code that I just showed to you. And of course, if you talk about getting a new functionality, you would also need to think about what is the freedom that you are losing here. Are you losing any freedom to modify the, let's say, the toString method that you had for your data class? If this is what you want, then perhaps you can go back to using the Java class that we already have to define the record classes. But yes, with new functionality, there would be some restrictions. So as I mentioned, you could use the same class to define data for multiple purposes, but if you try to do that, you would have to make different tweaks here and there, because one size doesn't fit all. So if you're trying to use a regular Java class to define records, then you would get a lot of boilerplate code, but with record, you would have to give up some of your freedom. And this again would be syntactic sugar, because behind the scenes, the compiler would create a full-fledged class for you. But of course, you as a developer would not have to read or write so much of code. So we'll quickly talk about the seal types, which would be coming to Java sometime soon. In this case, what we try to do is we create more boundaries for which class or interface can extend or implement other classes or interfaces. So this would again, so if you go back to the switch expression example which I showed to you, we were talking about checking the exhaustiveness of a parameter. So this could be useful when I talk about pattern matching in the next section, where we talk about checking the exhaustiveness of a type of variable that you pass. So concise method bodies. I'm sure the ones who are already working with lambdas would love the syntax. So this is how we define our regular methods. A simple method where we have add 2 method parameters and we're returning just the sum of these. And with the concise method bodies, we would be able to align that with the lambda syntax. So this is how concise it would be. So pattern matching is again interesting. How many of you hate this? Using instance of and then using casting? All of us. How many times do you have to actually count the number of round braces? 2 or 3 or 4? 2 on the left, 4 on the right, 3, 4. I know, we all of us hate that. So this is how we could get rid of it. With pattern matching, when I say if object instance of ocean, of course we can assume that ocean is a class. Instead of casting, I could do this. So since this is still in works, the keyword matches might be replaced by another keyword, but the idea would be same. I have another variable which would be attached or glued to my OBJ variable, and then I say system.out.println without using those explicit cast. I could say o.getBottles. In this case again, I assume that getBottles is something that I have already defined in my class. So, oh, that's lovely. Thank you so much. So this is how the old and the new instance of operator compares. So this is what we have with explicit casting, and this is what we would get when we have pattern matching. So we could, okay, so let's skip this one. Okay, and if I go back to the seal type, so with pattern matching and the seal types and the switch expressions, I could actually switch on a variable type and determine whether it's of a particular type, because with seal type I can actually seal which classes or interfaces would extend it. So that's the last one for the day, for the session, sorry, enhanced enums. So this is how we define an enum. And did you know that you could define individual members to an enum constant? So how many of you have actually tried to add members to your enum constants? Some of us? Yes. But have you actually tried to access those constants or the members that you defined for the individual constants? No. You didn't try because that will not work. If I try to access the variable and the method which I defined for one particular enum constant, I cannot access it. Because if you remember, whenever you anonymously extend a class, you get a new class, and the name of that class is determined by the compiler. Some of us, yeah, will agree with that. So if I do not know the name of that class, I cannot use the members. So the same thing happens with the enum constants. If I define new members for an enum constant, I cannot access it. But with enhanced enums, this would be possible. So this is how the compiler sees it. It cannot, as of now, it cannot see the new members or the methods or the variables which are defined for a particular enum constant, but with enhanced enums, it would be able to do that. And of course, with enhanced enums, Oracle is also planning to add generics to enums. As of now, we don't have generics with enums, but with enhanced enums, we would be able to get it. So quick examples. So as you can see, enum size, T extends measurement. So these are some of the examples which show how enhanced enums would be enhancing the existing enums. But this part in Project Amber has been put on hold due to multiple complications. So not a lot of work is happening on this part as of now, but yes, it might pick up as we move forward. So this would be interesting, how you would be able to define generics with, add generic information to enums, and this is how you might be able to use those enhanced enums. So the message for the day is change is constant, and I encourage you to embrace it, because if you may take smaller steps and change every day, then taking a bigger step and making a bigger change would be easier for you. Thank you so much. You all have been a lovely audience, very interactive. Thank you very much.